Hey guys, this is Mr. Garrett here, and this is our new way of learning. So we're going to be taking notes today. As you read in your school messenger yesterday, I do apologize, however we had some technical difficulties with making this video, but you guys are beginning algebra. As you can kind of already notice from our notes, algebraic, that's one of the first words that stands out. So moving forward, this is going to be our format. I'm going to write the notes out. So if I'm writing them out, you can write them out. Write these down, copy them in your notebooks. These would be good questions to use, good material to study for, any tests, quizzes, or assignments that you still have while we're doing e-learning. Now, with that being said, let's go ahead and get started. So we have Chapter 1, Lesson 1, Variables and Expressions. And guys, if at any point I'm moving too quickly and you're not able to write all this down quick enough or move with me, because again, mine are pre-wrote, go ahead and just pause the video, write down what you can see on the screen, and then move ahead with me and we can kind of move together as a class then. So let's make the best out of kind of a bad situation right now. So as we get started here, we have variables and expressions. This is the beginning of algebra. And algebra revolves a lot around variables. So that's our very first vocab word, variable. And all a variable is it's a symbol. Now, I put the letter X next to it because in algebra, and as you get older, you're going to see X a lot. And X is probably going to be used 90% of the time whenever we have a variable. And a variable is nothing new. It's an unknown. We don't know what this X stands for. It's just an unknown term. And you guys have been using variables for the last couple of years now. Our next term that we have is an algebraic expression. And there's a key word here in algebraic expression. It's a mathematical phrase with one or more variable. And that's the key here, one or more variable. An example of this would be if I had 3x plus 2. That's a mathematical phrase. It's an expression, and if you need help remembering that, expression there has no equal sign. So I don't have any equal sign in this 3x plus 2. It's a mathematical phrase, and it has one or more variable, and that variable just happens to be x, and the x is being multiplied by the 3. Our next phrase is going to be a numerical expression. And in a numerical expression, this is where it gets different than an algebraic expression. It's still a mathematical phrase. It involves numbers and operation symbols. If you forgot what those operation symbols are, we can list those below here. They are addition, subtraction, multiplication, and division. Numerical expressions do not have any variables. So again, if I want to write an expression with no variables, let's start with something simple. 2 plus 2. That's an expression. There's no equal sign. It's a mathematical phrase. It involves numbers and an operation symbol. My operation symbol is addition. There's no variables. There's no unknown anywhere in this. So there you go. There's your algebraic expression and your numerical expression. As we move on now, we move into kind of some of our problems, and this is what some of our problems are going to look like moving forward. So number 1, we have 32 more than a number x. And what I want to do is, I want to turn this word form into standard form. So I have 32 more than. More than means we're going to add. So it's 32 more than a number. So I'm going to start with my number. I don't know what it is, so it's x. And it tells me what variable I'm using. So x plus 32. And that would be my algebraic expression for that problem. X plus 32. Order matters here, guys. X plus 32. 32 is more than this number. So I'm starting with my x. I'm adding 32. Number 2. if 58 less than a number x. So again, 58 less than refers to subtraction. So 58 is less than a number x. So I'm starting with that x. 58 is less than that number. So it's going to be x minus 50. Excuse me, guys. 58 is less than a number x. So 58 minus x. And that would be our expression for 58 less than a number x. And the reason, guys, our order matters on these types of problems is because, say, for example, the way that if we were to turn this around, and then we were to write x minus 58. Well, if I put a 2 in for x, 58 minus 2 is 56. 2 minus 58 is not 56. So I'm not getting the same expression or the same answer for both expressions. So our order does matter when we're solving these types of problems. So this one would be 58 minus x. Moving ahead, our next problem, number 3. 8 times a number y. Times, pretty straightforward. We're doing multiplication, so I'm doing 8 times a number y. And as we get older, guys, we move into algebra and some higher math levels. Whenever we do multiplication, we always write the number and the variable side by side instead of putting the multiplication symbol. And we do that because the multiplication symbol that we have up here in the top corner is an x. So if I were to, maybe this variable was an x, 8xx. Looks a little different, a little funky, so we just simply write these side by side. So 8y. Number 4, the quotient of a number z and 5. Quotient, every one of us should know that quotient is division. So I have a number z divided by 5. The quotient of a number z and 5. So it's going to be z divided by 5. Another way of writing this, whenever we do division, and again, this is kind of similar to the number 3 here, another way of rewriting it is going to be z over 5. Because fractions, the fraction bar is the same thing as doing division. So either one of those answers would be acceptable. Now, as you notice, every single one of these guys is just one step. We had just addition, just subtraction, just multiplication, just division. Things are getting a little tougher. As we move on to number 5, we read this one. We have 3 more than twice a number x. So now we want to try and identify what are the operations that we're going to be using. So 3 more than. Well, anytime we see the number, we see more than, we're going to be thinking about addition. So 3 plus twice a number x. Well, if I'm taking twice of something or 2 of something, that means I'm multiplying it by 2. So 3 plus 2x, because it's twice of x. So x times 2 here. So our final algebraic expression is going to be 3 plus 2x. Number 6, we have 9 less than the quotient of 6 and a number x. So again, we have the words less than, that refers to subtraction. We have quotient, that refers to division. And guys, as I'm sitting here underlining these and throwing the operation above them, it's not something you have to do when you solve these problems. However, it might help you as you're going through this, especially since this might be a little new to some of us. But notice our wording here. 9 is less than the second part of this sentence here. 9 is less than the quotient of 6 and number x. So if 9 is less than this part, then I know I'm going to have the quotient of 6 and a number x, so 6 divided by x, come first, because 9 is less than whatever this 6 divided by x is. So 6 divided by x minus 9. And that is going to be our final answer for number 6. Notice, guys, on all of our problems here, 1 through 6, we didn't have an actual concrete answer. None of these were equal to anything. And the reason they aren't is because there's no equal sign. They are all expressions. Moving ahead, number 7, we have the product of 4 and the sum of a number x and 7. So as we solve this one here, we have the product of 4 and the sum of a number x and 7. So another two-part question here. The product, that refers to multiplication. We have sum, that refers to addition. And guys, I apologize for some of the blurriness on the screen. Let's see if it sets itself back here. There we go. It's kind of zooming itself back in. So the product of 4 and the sum of a number x and 7. So if we do this here, product, that means multiplication. So I'm multiplying 4 by the sum of this number x and 7. So if I'm multiplying 4 by this sum, then I'm going to have x plus 7. And then I'm multiplying this entire thing by 4. And guys, when we do that, when we multiply by 4, we can simply use parentheses and show that I'm going to distribute that 4 into everything. Because I'm multiplying 4 by this quantity, this x plus 7. So that then would be our final answer for number 7. Moving ahead, as we move on and we kind of finish out this lesson, guys, number 8, 9, and 10, notice the expression is given. We don't have any words, and that means we need to put these into word form. So for number 8, I have just 3 and x. So if I were to write this out, it would be 3 times, and we're not going to write the number 3, we're going to write the word 3, 3 times, and what are we multiplying by? We're multiplying by a number x. And we have to do that because we have to show that we're multiplying it by that variable, and that variable is a number. It's not anything that's irrational, it's not an imaginary number, it is a number x. Next one, number 9, x plus 15. Think about our operation. We're doing addition. So we have the sum. Well, what are we adding together? We're going to take the sum of a number x and what are we adding it to? Well, we're adding it to 15. So the sum of a number x and 15. Number 10, last one. 10x plus 9, and I'm going to move a little quick on this because my recording has a time limit, so we're kind of running short on our time limit here. 10x plus 9. Well, I have two terms that I'm adding together. So I'm going to have the sum of, well, what am I adding together? I'm adding together the sum of 10 times a number x, and I'm adding that to something. I'm adding it to the sum of 10 times the number x and 9. And as I go through here, I notice I need to change this to 15. There you have it, guys. That is our first section notes. Your story problem we posted in another video. Watch these, get them in your notebooks, and I will be back with you shortly.